We've all been there. You get a wild idea for a spicy new cookie, throw a bunch of random ingredients in a bowl, and end up with a smoking disaster in your kitchen. This is why we test recipes in small, controlled batches. It is the only way to catch a mistake before you bake a huge amount and risk making everyone sick. Aerospace engineers use this same logic to manage the high stakes of building a billion-dollar spacecraft. Putting an unproven idea onto a massive rocket is an enormous risk to human life and years of hard work. To solve this, NASA uses the Technology Readiness Level scale, or TRL. Think of it as an official thermometer that measures exactly how real an invention is, from 1 to 9. The TRL scale acts as a safety protocol. It ensures that scientists don't bet a critical mission on a theory that hasn't been proven step by step. The first 3 levels are the idea phase. This is the equivalent of sitting at your kitchen table, writing down ingredients, and guessing if they will actually taste good together. In the lab, this translates to levels 1 through 3. Engineers work on whiteboards here, using math to verify the physics. While the math looks good, these early levels are still just pencil and paper work. There isn't a physical machine yet. This stage is about proving an idea is scientifically possible on paper before anyone spends the money to build it. Once the math holds up, we enter the kitchen phase. The experiment becomes physical as you mix those ingredients and bake your first test batch. Level 4 is a breadboard validation. Early inventors earned that name by literally pinning wires and bulbs to wooden breadboards to create rough prototypes. Levels 5 and 6 move the test into a relevant environment, like seeing if a recipe survives the oven. In aerospace, engineers put these early prototypes into giant vacuum freezers that simulate the extreme conditions of space. This phase transforms a math equation into a physical, working object, even if it isn't ready to fly just yet. If your recipe survives the oven, it moves to an industrial bakery to be produced for the real world. This brings us to levels 7 and 8, where the final system is built and put through its most difficult real-world tests. The final goal is level 9. This text confirms that the technology is now flight-proven through successful missions. Reaching level 9 means the technology is currently in space, performing its job exactly as designed. This is the ultimate seal of approval. It proves the invention is reliable enough to trust with human lives and critical missions. Invention is a step-by-step journey along this 9-level scale. You can use this scale to understand the news. Imagine seeing a viral headline about a miracle 100-year battery. The scale helps you look past the hype. You can identify if that battery is just a level 2 sketch in a lab compared to a level 9 product ready for your car today. Understanding TRL gives you a practical tool to judge how close a scientific claim actually is to reality. Science is a careful, methodical process for turning our imagination into reality.